Okay, guys, so we are going to model beam 2 in ETABS, and I will show you what are the steps, how you can proceed in modeling and analyzing this beam in ETAB. Now, you guys know the dimensions of this one, which is 6 meter, 8 meter, and 8 meter spans. Now, you can start from left to right or from right to left. It will not change any results. So what I'm going to do is I will start with 6, 8, and 8. So this is our ETAB software, which you guys are going to get when you will install ETAB in your PC. You will get this logo on your PC. Now, once you turn it on, you will find that there is a new window appear in front of you, which includes the opening page. If you see here on the left side of the screen, it will tell you that you have to start with the new model or with the existing model. If you have any existing model, you can open that one. Okay, I'm sharing that one. Is it what about the others? Because maybe stuck with you guys, others can see. So yeah, just if you find anything stuck, it's recording. You can see later on the recording. Maybe your internet is working very slow. Watch all other pieces. Yeah. That's why I was saying that you can connect it with the desktop because there is DSL cables. So better if you can connect with the cable. Okay. Now, once the new window is opening, you can find that there is a new model or existing model option. You can start with that one if you have an existing model, but we have to develop our own model. We have to model it ourselves. So what I will do, I will go and click this to the new model. This is one option I have. Another option is that I can go to the file, click on file, and then say new model. Once I click on that one, it will show me a new window where I have to select the units for my problem. Now, what is the units we are going to use here in this problem? The units are SI, metric units. So instead of using the user safe units, because this, if you observe here, previously I have worked on the US customary system, which was metric system. So I need to convert this system into another unit. So what you can do, you can click on use built-in setting and you can come and change your units. Now our units are here, metric SI. So I will click on that one. Now, what is the region you are focusing means which region material you are focusing. Now our local region is not available in the system, so I will just go to United States because we are using American code, ACI code. So I will use US United States as a region. Then if you are modeling in steel, you can choose the steel code. And if you are working in concrete, you have to choose the concrete code. So if you observe here, steel sections database, it is from the steel manual. If you are like you guys are studying in British standard, your steel course, so you can come here and click on this option. You will find British standard shapes are also available. But if you want to work in American code, so it is AISCE. You keep it as it is. Next is steel design code also. You want to change or not, it depends on your type of problem. So here we are working only in the concrete. So I will choose ACI code. Now you can see here by default, ACI code 31819 is available. This is the latest version already in the system. But if you are working in any other old code, you can come and you can change that one. Now we are going to use only the latest one, because all our problems we are solving from the latest code. So I will choose ACI 318-19. After this one, I will say OK. Once I click on OK, a new window will appear in front of me, which will ask me for the grid lines. Now, what are these grid lines? These are reference lines for you, where you are going to model your structure. If you are going to model in three-dimensional, you have to define the grid lines in X, Y, and Z. Now, X, Y here, if you see on the left side of the screen, grid dimension plan. Plan means X, Y. Your third dimension, which is height, is shown here in Z direction. And your plan, it is always shown in X, Y direction. So what do you think? In our case, if I'm modeling this problem as a 3D, uh, like the building we have, I have to give all the grid lines there. And we saw those grid lines. You can see here, you have grid lines in uh, X direction, any direction you can choose here as X and Y. So if you are considering this side as X and this side as Y, so in X direction, how many grid lines we have? 1, 2, 3, 4, 5, 6, 7. Now, the grid lines in your plan is shown as A, B, C, D. But the grid lines which I'm talking in the software, it is related to the location where you want to model your beam or your column. Now, if I miss that grid line, which is showing B2, I will not be able to model beam there, because if I put only four grid lines, which is A, B, C, and D, software will show me only those four lines. So how you are going to model B2? So in your software modeling, the grid lines which you are putting in the plans, architectural drawings, they are totally different than your software grid lines. So in grid lines here, I'm talking about in the software is the location where you want to model your beam or column. Now, this problem which we are working on is two-dimensional, means I'm just working only in the beam modeling. So I don't want to model currently a full building. Full building, you will work in your project. Now, if I want to work on only in two-dimensional beam, what should I do here? I can come here, put any number in X direction. Minimum should be 2 grids. You can just, what is the grid spacing? You can keep 8, 8, and then we will edit them, because you cannot put 6, 8, 10, multiple grid lines. We cannot put that one. I will show you the option how you are going to change the grid line. Then I don't have number of stories because I'm just modeling only one beam. So I can put only 2 stories here and keep the spacing as it is. This is has nothing to do in your two-dimensional modeling. Once you click on this one, okay, you will see that grid lines are going to come on our screen. Now you can see on the left side of your plan, left side first window is indicating the plan, and on the right side you have 3D view. Now, how we are going to model our own grid lines? Because now for 2D problem, I need my own grid line. So you can click on this window, right click on this window, and you will find add and modify grid data. Now, remember in ETABS or STEP 2000. These are two softwares which are similar to each other. If you learn one of them, you can go with the other one. Now, when we are working in two-dimensional problem, it is best to model in X, Z direction. For 2D, XZ is the one which we are going to consider. X is representing the plan and Z is representing the vertex, because your moment diagrams will be easy to get. You can model it in YZ also, but best approach is take elevation XZ, which will give us easy access to get our moment diagrams for any member. So I will click on add and modify grids data. I will go and click on modify show grid. Now, when you click on this one, what is it indicating? I have a 0 node, then next B at 8 meter. Now, what is our first dimension we are taking? 6. So I will put here 6. Then I will click add another grid line. What is our next? 6 plus 8 is 14. So I will put 14. Next, add 14 plus 8, 22. So by default, next software already added 8 to that one. Now, in Y direction, I don't care because I'm not modeling anything in Y direction. I'm going to model everything in X and Z direction. So I already put grid lines in X. And if you see on your right side of the screen, there are multiple lines are now appearing, which is indicating your grid lines. Now, once I click on OK, I will go back, refresh and click OK. You will see here now, this is our plan. Now, it is a plan in X, Y. But what I need is I need elevation. I need elevation because beam is always modeled in elevation. And results for the beam can be seen only in elevation, moment diagrams. And so I will go here and click on elevation and which line you want to see. If you see here in 3 dimension, there is XZ shown. So this is your first grid line. I will click on one. And when I click on one, you can see here now this is like a 2D frame shown. It's a grid line, but indicating like a 2D frame in front of me. Now I can model my beam here, anywhere because I'm not modeling it in 3 dimension. I'm just taking one part of the beam and I have to just work on that beam. So what I will do here, I will just model it at this level, story 2 level. It's an arbitrary story because I define a 3D view, but it has nothing to do with your results because you are not modeling anything in Y direction or in Z direction. Okay. So how you can model the beam? Next task is to modeling the beam here. Now, if you observe here on the left side of your screen, you will find multiple options for different type of element. Now, if you bring a cursor here on each option, you will find a message below that one, draw beam or column in plan or in elevation or in 3D. So this is one option. Then you have another option, which is indicating quick draw beam, which is also for the beam. So beam and columns are always modeled using the line element. Now, if I go to the next option, it is indicating quick draw bracing. If you have a bracing system in your building, you can use this one. And next option is related to draw floor or wall system. So these options you are going to explore in your 3 dimensional structural system. So I will just go with these first two options. If you observe the first two options, there is some difference between the line mark. Now, the first option is always used to connect your grid point to point. If I click here, you can see here after first click, the cursor is moving and there it is indicating the dimension here. When I reach to the 6 and I have to click it again, you will see that now a blue line is appearing. This blue line is indicating a beam is modeled there. Now, this is the first option, which gives you connect 2 points together. If I just press on escape, this option is finished. Now I want to show you another option, which is the second one. Now this second option, it will not connect node to node. It will help us. If you click on the line, you can see here, when I'm bringing this cursor, it is directly picking the line. And if I click on this one, it will directly model the beam without taking from one node to another node. But in this case, you guys have to remember that grid line spacing must be correct. If your grid line spacing is not correct, what is it going to take? It is taking the same space where you are putting your cursor. So that's why I define already 6, 8, 8. Now you can define any line and then take two node to node points and connect your beams there. That option can be work, but best approach is your grid lines must be defined before you start modeling. Now I have, this is 8 meter already modeled. Next is, I will just bring a cursor again here. When I click, next 8 meter is also modeled. Now this line is representing, the blue color line is representing that beam is already modeled there. But we didn't define the properties of this beam. Now, if you remember, when I was clicking on this one, there was an option appearing on the left side of the screen. See, whenever you click on any of these options, and you can see here the color of that option become blue, means that option is activated. Now, if you see here on the left side of the screen, there is different type of beams available. Now, it is a frame element, property, what beam I model a latitude beam. Now, what is this? These are different type of beams available with us. Now, I didn't choose concrete beam. I didn't choose. So what happened by default, the software is giving me option of ALAT beam. Now, this beam has some properties. How we are going to change those properties? Because your beam is concrete beam. So I deliberately model it like this way because you can edit your properties quickly. Now, I already model, I don't care about these properties. I didn't define them from the beginning. So what can I do here? I can first go to the define. Now, modeling, this is modeling. Nothing has to be done with the properties. First, I will go to define. Now, I will come to the material property. Let us define first material property. Now, in the define section, you will find multiple properties. I will click on material property first. What is our material? Reinforced concrete. Now, if you see here, there are 4 materials already available. First one is indicating steel. Third one is also steel. Fourth one is also steel. But wherever you find 4000 psi written, it is your concrete material or reinforced concrete material. Now 4000 psi means 28 megapascal concrete. So because this software is developed from US, so they will always write everything in terms of foot pound system. So I will click on 4000 psi. I can take the I can copy this material because I want to define my own material. But every property of this material I will take, except I will change its concrete strength. So what I will do, I will click on add copy of this material. When you click on add copy of this material, it will take density of the concrete, everything by default, and give you a new option to name that material. I can call this now reinforced concrete, RC, whatever you want to call this material. Now you can see here, it is a concrete material by default. You have multiple options here, but we don't want to change. It is a concrete, so I'll keep it concrete. Next, you need to define the density here. Now, there is one issue with us now. When I model that beam in the class, when I was solving that problem in the class, what I did there in the class, I said that I will calculate the self weight and I will add that self weight to the superimposed dead load. Now, if you keep density here, what software will do? It will start calculating the weight of the concrete by itself. So to keep that option off, what you can do here, you can put density equal to 0 because you already added your self weight in that dead load, which I did yesterday. When I was solving that beam, what I did, I added the dead load into that total load, the self weight. So I don't want software to calculate the density or the weight of the concrete. So I will put density here 0. But if you want software to calculate the self weight of any element, you need to put the densities there. Is this point clear? So I will put density equal to 0. About modulus of elasticity, currently I don't need this one because modulus of elasticity will be available when you are dealing with the design part. I'm just currently developing only the moment diagram. I have nothing to do with this one. But if you are working in the design, then you have to define your FC prime and get the modulus of elasticity from that one. And we have seen that formula 4700 times square root of FC prime. So you can get that modulus of elasticity from that formula and you can plug it here. So I will not change anything here. Only the thing which I want to change was the density, which I kept 0 because I already added that weight in our load. So I will click here, OK. This is now our material, which I define it as RC. Now, next thing is I need to define the cross section of the beam. How we can define the cross section? If you go again to the define option, you will find second option is what? Section properties. You will come to the section properties and you click on frame section because beam and columns are modeled as frame element. So you will click on this one. Now, what is the type of beam we have? It is a rectangular beam. There are multiple options. You can see here all the steel sections, concrete beams of different sizes are available here. But if you want to define your own size, you will go here and click on add new property. When I click on add new property, what is the type of element I have in concrete? It is rectangular section. I will click on this one. I can name this as B dash 2 because this is what our beam I'm naming in the plan. What is the material property? I already defined that material property. I will click on this and it will show you the options which you already defined. So I will click on RC. What is the size of the beam? We have seen yesterday, I fixed this size as 500 in depth and the width of the beam was 350. Okay. Now you can see here when I'm putting these sizes here, what is happening on the side of your screen? The size of the beam is changing. And you can see here, there is a reinforcement shown inside that beam. Now, for the time being, there is no problem because you are carrying out only analysis. But if you are carrying out the design, so what should we do here? You have to come and click on reinforcement. When you click on this reinforcement, if you see here, what it is showing us, design type, considering it as what? Column. You have to click it on beam and I will come here. If you define the longitudinal bar, you have to talk about the longitudinal bar and you have to give the size bars, what size of bars you are using. But we are not designing here. Only I need to change is I need M3 for the design. I will click on OK and you will see here reinforcement is gone out of the system. I just need to analyze and when I will design, then it will provide me the reinforcement with the properties of the steel which you are using here. But for the time being, I'm not going to the design because everything you are going to do from this software is analyzing your structural system. Now, after this one, I will click on OK. Now, this is our B2. I will say, okay. If you don't click on this option, okay, you by a mistake, you click on cancel, everything is not defined. You have to come back and define it again. So don't go without clicking on okay. Once I click on okay, now in the system that beam is there. Now, just to give you an idea here, if you click on this beam, right click on this beam, you will find what I defined here, this beam. It is showing what? W24 slash multiply by 94, which is steel section. I don't want this steel section. So what should I do? I will select all these beams and I will go to assign and go to frame, click frame property. When you click on frame property, your beam is appearing here. Now click on B2 and say, okay. When you say okay, you will see that now your beam has been changed to B2. And to verify, you can just right click on that one. You will find here B2 is defined. Now beam is defined. What is the next thing after this one? We have to define the support conditions. Now, how you can define the support? You have to go to assign button, click on this one, you will find first option, which is joint. Now, under joint, you will find restraint, spring, diaphragm, panel. These are different type of options to put as a support condition. In our case, these are external support. So what I will do, I will click on restraint. When you click on restraint, you will find your traditional symbols, which you are using in your structure analysis 1 or 2. Now you can see here, when I click on this first option, it is basically fixed support. When I click on this one, you can see here all these 6 options has been selected. Now in software, it is three-dimensional hinge or three-dimensional fixed support or roller. It will not change your results. If you are putting pin three-dimensional, when even if you are not running in the third dimension, your results will not change. But it is a hinge. In software, it will be always three-dimensional support. Now, our property was what? Our property was pin. Yesterday, we decided we are going to put a pin. Now, next option is pin. After that, it is roller. And the last is just free node if you don't want to put any support there. But now this will not work until I select the nodes where I want to put the support. So what I will do, I will go and first select these node. When you click on the node, a cross will start appearing. Multiple cross, I need to put a support here. I need to put support here. Now, what I will do, I will click on pin and then I will say apply and okay. You can see here the small triangles start appearing, which is your traditional symbol for the pin. Now pin is defined here. Next step is what? We have to apply the load on this beam. Now I will go back to our problem here and I will show you the load which I'm going to take here. This is the load which we are going to take first, which is basically self weight plus the load, superimposed load transferred from the slab and the weight of the slab itself. So I'm taking only service load here. And yesterday we calculated the service load was 21.68. Now I will use this load and I will come and I need to select these beams first, all these beams. And when you are clicking on that one, the beams, there is like dashed lines are appearing on that one. You go to assign and then if you go in assign option, you will find that there are joint loads, frame loads, shell loads. Now, joint loads are used to apply for the point load. If you have a point load acting on your beam, if you have a point moment acting on your beam, this option will work there. Now we have uniformly distributed load. So if you see here, the second option is frame loads. Now under the frame loads, again, you will find a point load because on the frames also you might have point load at specific location. Then you will find distributed load. And third one is temperature load. Now, if you are analyzing your problem for temperature variation that suppose on one side of the beam you have 0 degree, on other side of the beam you have 400 degree of Fahrenheit temperature. So you can even study the transformation of temperature from one end to another end. So you can apply the temperature load also on there. Now in this case we have only distributed load. I will click on distributed load. When you click on distributed load, there is a load pattern option is coming here. Now I have to define this option. Before applying the load, I will define this option. I just came here to show you these options. Now, if you click here, there are only 2 patterns shown to us currently, dead load and live load. Now, this dead load, which is shown here by default, this dead load is to compute the self weight of the structure. It is nothing related to any additional load you want to apply. Okay, this dead load. And I will close this option and I will go to the define to show you from where you can define the load pattern. Now, when you come to the define, if you see here, there is load pattern option. When I click on this load pattern option, the options which I showed you there, dead is there and live is there. Now, this dead, you will find always self weight multiplier as 1 there. Now, if you see against the live, it is indicating 0. Now, this 1 and 0 here means on and off. It has nothing to do with, it is like your electronic signals. 1 means on, 0 means off. So 1 means if I keep 1 here, the software is going to compute the self weight of the structure. If I'm going to put 0 here, software will not compute any self weight of any material which you are going to put there. Now, if, currently, I will not change this option because what I did to play with the software, I already put density there, 0. So even if we try to calculate the weight, there is no density. So automatically weight will become 0. But if you put density there, it will compute the weight. Okay, so there are two ways of playing. Either you put 0 here or 0 there. So I will not change the option. What about live load? Currently, I'm not applying live load. And for live load, we need to keep 0. 0 means I'm the one user who's going to put the weight there. Software will not calculate any weight because there are no options in the software. You put live load, software can get live load from the code and put itself. There is no option. So always live load, any other additional load you have to keep from your side. Now, what I will do, I will say that a new load combination because I want to apply 21.68 myself because this is I'm applying from my side. So what is those load? Those loads include self weight, superimposed load, and weight of the slab. So I will call it as dead load, new name, DL, which includes from our problem all type of load. So what is the next thing? You will just say add new load and you will see here what is the option coming? 1. So is the software is calculating this? No, because I'm the one who's going to assign that 21.68. So what I need to do is I need to keep 0 here and modify this one. Okay. So after this one, dead load, what is that type of load? It is dead because I'm applying a dead load in terms of number. If you have any other load like wind, snow, you can click on this type and you will find all type of loads available in your software, but you have to define it. It is what type, because if you don't define this type, software will not create combinations. 1.2 dead plus 1 point live or 1.2 dead plus zero point 0.9 wind. So you have to define the type so that software can create combination. Now here we are running only for one combination, which is only the dead load. So I will not change. I will just say here dead load and I will click on OK. Now I go back to assign. I will come to the frame load, distributed. And when you see here, now your dead load combination is available. Click on this pattern. What is the next thing? I need to define the load, the value which I am taking. Now, what is that load value? Is it trapezoidal load? No. So I cannot use this option. It is what uniformly distributed load. So that is our option. And what is the load? We have 21.68 kilonewton per meter. And this load should act in which direction? Downward. So gravity means downward. If it is acting in any other direction, you have to change that. If it is acting locally, it depends on problem to problem. Now I will not change because it's acting downward. So I will keep it as gravity and I will say apply and click OK. Now you can see here all your load is there. After defining the load, everything last step is to analyze this beam. And if you see here, there is at the top, analyze option is there. You click on analyze, then run analysis. before that, if you want to check your model, there is an option now. ETAB is giving us check your model. If there is any error in your model, it will tell you quickly. Now you want to check it, you can just click on this one and say option. You can select all the options. Maybe there is any node is not connected, any hinge is missing, instability is there. It will quickly check for us. If you want to do that one, it is for your 3D models. When you are working on your 3D models, you have to run this. Now you can see here, model has been checked, no warning message are generated, mean there is no error in the model. So this you need to do in your three-dimensional models. Now I will go back to analyze and I will click on run analysis. When you click on run analysis, it will ask you to save your model, and you can save your model anywhere on any location where you want. So I will just keep this one and I will call it as B2 and I will save it, and it will run quickly because it's a two-dimensional. It will not take too much time for this software to give us the result. Now I will click on, okay, now you can see here, there is no error, but there is two warnings. What are those warnings? If you observe here, there is no mask. There is no mask because what I did, I put a density equal to 0. So it is nothing related to your problem because it will give you that material which you define. It has no weight because I default, I close that weight. So it will not affect our results. Only our results will be affected for the dynamic analysis. So I will click OK and analysis has been done. Next thing is to see the moment diagram. If you click on M3, this is the option for moment diagram. I will click on apply and OK. Sure. Okay. I need to see for the load combination. Our load combination is DL. When I will say apply and OK, you can see here moment diagram is there. Now, how you want to see the numbers, you will just click here. You can see here there is option fill diagram or show value. I want to see the values. You can see here, these are the values shown on your moment diagram. And if you compare these values, you will find the same values, which I'm going to show you in your class slides. So next, you can see the shear force diagram. For shear, you need to click on shear to 2 option, and you will see there is a shear force diagram here. If you want to see the reaction, you can click on this option, and you want to see in which direction reactions will be in upward direction. So FZ, when you click on this one, these are your reactions for the support conditions. So we'll stop here and inshallah we will continue with our topic, and you try to model the other beams available in the class slides with different load patterns and try to see if you can match the results which are available in the class slide. Okay.